This video is part of a series of instruction videos on the BioGrace greenhouse gas calculation tool. This is instruction 1.4, navigating to the BioGrace Excel tool. You can open the Excel tool from the zip file on the website. This was part of a previous instruction video. After opening the tool, you click on Continue to find the directory sheet. Here you see that the tool contains several sheets. First of all, there is a sheet About, giving some background to the Excel tool. Next, there are several sheets containing the greenhouse gas calculations, one sheet per combination of biofuel and feedstock. So, for instance, there is a sheet for ethanol from sugar beet, one for fame from rapeseed, and one for biogas from wet manure. Also, there are a number of sheets of more general nature, like a sheet for calculating land use change, a sheet for calculating improved agriculture management, and a sheet for calculating greenhouse gas emissions associated with N2O emissions from the field. Finally, there also is a sheet called User-Specific Calculations, and there are two sheets with standard values. We will come back to these sheets in later parts of this series of instruction videos. In this part, we will concentrate on one of the calculation sheets. Let's open a calculation sheet, for instance, ethanol from sugar beet. When you see such a sheet for the first time, you might find that the amount of information is overwhelming. I'll guide you through all information, and within a few minutes you will be familiar with the tool. Basically, there are two separate parts to the tool. A part on top, where you will find all results, and below a part where all the detailed calculations are made. Let's first concentrate on the part on the top. In the title row, you see which pathway we are working with, in this case ethanol from sugar beet. Then, in this result box, you will find all the separate steps of this pathway. They are clustered into cultivation, processing, and transport. You can understand that the first step is cultivation of sugar beet, then transport of sugar beet, then processing into ethanol, and finally transport of ethanol to a depot, and then from a depot into a filling station. In column B, you will find the unallocated values, and in column D, the allocated values. Allocation is done when co-products are formed, such as sugar beet pulp in this case. Part of the greenhouse gas emissions, to the point where the co-product is formed, are allocated to the co-product. More details on allocation can be found in paragraph 4.2 of the calculation rules. The allocation factors that are used are calculated lower in this sheet and are listed here and here. In column E, the final results are listed as expressed in grams CO2 equivalent per megajoule of the biofuel produced. They can be compared with the default values given in RED Annex 5 and FQD Annex 4. In order to calculate a percentage emission reduction, the final value in cell E17 is used together with the fossil fuel comparator, this value here, giving a result of 52% emission reduction, here. In column F, you will find three boxes with an A. These three small boxes allow to use disaggregated default values, as will be explained in a later video instruction. Column H gives the default greenhouse gas emissions as given in the RED. The BioGrace tool serves two functions. In the first place, of course, the tool allows you to make actual calculations. In the second place, it allows the user to understand how the default values from the RED were calculated, as the calculations that you find when opening the tool exactly follow the calculations that lead to the default values. In order to do so, I have to click this box here. This will be explained later. Now you can see that the results in column D and column H are almost the same. This box here allows you to switch between following the calculations of the default values and making actual calculations. This box is needed as some background values are slightly different for these two users. This has been explained in more detail on the About page. When you go here to About and then scroll down to this section, Inconsistent use of global warming potentials. Most probably this box will disappear in the next version of the BioGrace Excel tool. Last but not least, there is the Track Change button. This button allows to change between the for compliance and the for testing version. If I make a change in the tool with track changes on, like this, then it will be marked. If I would turn track changes to off, then the change will no longer be marked. There is a later video instruction with details on track changes and the for compliance versus the for testing version. In the second part of the tool, below here, you will find all the separate calculations. Scrolling down, we find all the steps of this biofuel production pathway: the cultivation of sugar beet, transport of sugar beet, ethanol production, etc. An allocation is a separate box, as you see here. There will always be an allocation box after a processing step in which one or multiple co-products are formed. This part is used to make actual calculations. You will typically replace the values in the cells with white background and green numbers. You should note that certain rules apply that can be found in the BioGrace calculation rules. One such rule is that when you replace one input value by an actual value, in the cultivation for example, then you must replace all input values by actual values in the cultivation. In columns I, G, K and L, all results are expressed per megajoule of the final fuel. This needs information from the whole ethanol production pathway, so the results of the cultivation can only be expressed per megajoule of ethanol if, for instance, the efficiency of ethanol production from sugar beet is known. Sometimes a user wants the information that is independent of later steps, and for this reason 1 or 2 columns for information are added, in which the results are expressed per kilogram and sometimes also per hectare and per year. Last but not least, the tool is not protected, causing that the user can insert rows, like this, and can copy information with copy-paste, like this. And the user can change formulas in the calculations, like this. Here I have to add a small remark. In the for compliance version, the format of cells cannot be changed. It was decided to allow so much changes in the tool as this can be needed for greenhouse gas actual calculations for pathways that are rather different than the standard ones. Of course, more complicated changes should only be made if the user is familiar with Excel and with the tool. In later parts of the series of instruction videos, some examples will be given.